It was excellent. Thank you for asking. All right, today we're going to be using area formulas. You're going to be using area formulas to find missing dimensions. All right, the area addition postulate. I don't know that you're going to be using it till later on, but area addition postulate. Says that the area of a region is equal to the sum of the areas of its non-overlapping parts. The sum of the areas of its non-overlapping parts. So what that means is if you were given a shape and you were asked to find the area of this shape, you don't have a formula for the area of a pentagon unless it was a regular pentagon. So in this case, there's not a formula for the area of this shape. But what you could do is you could split it up into a couple of shapes. You could split it up into a triangle on the top, right? And a rectangle on the bottom. And you could find the area of the triangle and you could find the area of the rectangle, and then you could add them together. Okay? So that's what the area addition postulate says, that the area of a region is equal to the sum of the areas of its non-overlapping parts. Anytime you get a shape like that where you don't have a formula for the area of it, break the shape down into shapes that you do have area formulas for, and then find the area of each and add them together. Alright, so right below that, area of a parallelogram. With base B and height H is the area equals the base times the height. And a parallelogram, remember, has two sets of parallel sides. base and height. When you're finding area and you're dealing with base and height, keep in mind that the base and the height are always perpendicular to each other. The base and the height are always perpendicular to each other. Sometimes in these parallelograms you'll see the height out here. You'll see an extension of the base. And you'll see a picture that looks like this. And you may be given the height out here. But that segment, that dashed vertical segment, and this dashed extension of the base are perpendicular to each other. So this dimension would represent the height of the base.
The base would be the parallelogram and the extension, right?
No, the base of that parallelogram would only be this piece right here. This dashed part that's the extension is just used as really notation.
Oh.
It's just showing you that the base extended intersects with the height at a 90-degree angle. When we get into trapezoids, you'll need this dimension right here and the height to find, one of the sides, but not right now. All right, so look at example 1. Find each measurement, the area of the parallelogram. So actually, you're going to be using that right here.
What page is it on?
677. You're given this base as 6. You're given this angle dimension and 3 right here. You're asked to find the area. So if the area is equal to the base times the height, well, the base is 6. But the height is this side of this right triangle. And this right triangle has one side of 3 and one side of 5. So you can use the Pythagorean theorem here to find the height of the triangle. So 3 squared plus h squared equals 5 squared. So 9 plus h squared equals 25. If you subtract 9 from each side, then h squared is equal to 16. And if you divide each side, or if you find the square root of each side, then h is equal to 4. So now you've got the base of the parallelogram and you've got the height of the parallelogram. So the area is going to be equal to 6 times 4, which is 24. Top of page 678. You're asked to find the height of a rectangle. In which the base is equal to 5 and the area (5x squared minus 5x). Alright, so the area. Find the height of a rectangle in which the base is 5 and the area is equal to 5x squared minus 5x. So you're going to use the area formula in this case to find the height. And the area of a rectangle is equal to base times height, right? So now substitute. Substitute your b and substitute your area. So where the big letter A is, you're going to make it 5x squared minus 5x. And that's going to be equal to b, which is 5, times the height. So in this case, how would you solve for the height? You divide both sides by 5. And just be careful when you're dividing this binomial by 5, because you have to divide everything by 5. So 5x squared divided by 5 is x squared. And 5x divided by 5 is just x. The 5's on the right cancel, and your height would be equal to x squared minus x. Questions?
Oh, that's.
Yeah, that's the answer. Yeah, when the area of a shape has a variable in it, then either your base or your height has to have a variable in it as well. Look at example C there, right below it. You're asked to find the perimeter of a rectangle. In which the area equals 12x. And they give you a picture of that rectangle, so it looks something like this. So in order to find the perimeter, you need the base and the height, so that you could add up all the sides. So again, you're dealing with a rectangle in which area equals base times height. If you're given the area, which is 12x, so substitute 12x equals, let's call this the base down here, and this is the height. So in this case, your area is equal to your base times your height, so 6 times whatever your base is. And if you divide both sides by 6, then 12x divided by 6 is 2x equals the base. So if this base down here of this rectangle is equal to 2x, and the perimeter of a rectangle is equal to 2 of the bases plus 2 of the heights, or you'll see it 2 length plus 2 width, you can substitute. So 2 of the bases would be 2 times 2x, plus 2 of the heights would be 2 times 6. So the perimeter of that shape is going to be equal to 2 times 2x, which is 4x, plus 2 times 6, which is 12. All right, on the bottom of 678, area. Area of a triangle. The area of a triangle is equal to 0.5 times its base times its height. Area of a triangle is 0.5 times the base times the height. And again, in a triangle, the base and the height are always perpendicular to each other. So in this triangle, this would be your base, and the segment perpendicular to that would be the height. Area of a trapezoid. The area of a trapezoid is going to be equal to, that is 0.5 times base 1 plus base 2 times the height. And in a trapezoid, the parallel sides are the bases. So this would be your base 1. This would be your base 2. And the height is going to be anything that's perpendicular to those. So this could be the height right here. All right, so example 2A on page 678 says, find the area of find each measurement, the area of a trapezoid. They give you B1, B2, and the height. So that's just a matter of substitution. I'm not going to do that. You substitute B1, B2, and H into the formula and you type it in your calculator. But I will do example B and C up on the top of page 679. So find each measurement. So you're going to find the base. Find the base of a triangle. Find the base. Of the triangle. In which the area is equal to x squared. And here's a picture of the triangle. So this x would represent the height, wouldn't it? And this is the base down here that you're trying to find. And if area equals 0.5 times the base times the height, you can substitute. So the area of this triangle is equal to x squared. So where the a is, you replace it with an x squared. 0.5 times the base times the height, which is x. So if you're solving for b, you divide both sides by 0.5x, right? You're trying to remove the x and you're trying to remove the 0.5. So if you divide both sides by 0.5x and divide by 0.5x, these cancel. So the base here is going to be equal to x squared divided by x is just x. And now there's a 1 in front of this x squared, isn't there? But it's not written, it's implied. So what's 1 divided by 0.5? It's 2. Good. So your base in this case is equal to 2x. All right, example C on that same page. Find B2, which is base 2 of the trapezoid. In which the area equals 8. And that trapezoid looks like this. So we got a 2, a 3, a base 2. All right, so you write out the area formula. Area of a trapezoid is equal to 0.5 times base 1 plus base 2 times the height. And now substitute everything that's given. So 8 is equal to 0.5 times base 1 is 3 plus base 2 is what you're trying to find times the height, which is 2. So right here, you can divide both sides by, you can take this 0.5 and you can multiply it by the 2 right now. What's half of 2? 1. So you can divide both sides by 1. And when you divide both sides by 1, or you're dividing both sides by 0.5 times 2. So these cancel and these cancel. So 8 is equal to 3 plus b sub 2. And you can subtract 3 from each side.
So you can always take the 2 numbers on the outside and multiply?
Yeah, because you've got a number next to parentheses, and then you've got addition inside the parentheses, and then that quantity times another number. So you can reorder that whole top if you wanted and make it 0.5 times 2 times 3 plus b2. Because it's all multiplication, right? So when you reorder it, you can multiply these two first, and you would have 1 times 3 plus b2. It's a little bit simpler. Okay, so down here you got 5 is equal to base sub 2. Any questions? Okay, your assignment for today and tonight is on page 681. One through 6. And then over on the next page, 11 through 16. This assignment's going to get collected at the beginning of class tomorrow. It will need to be 100% complete to get credit for it.
Should we do that one? Or just-
Don't do it on your notes. Do it on a separate sheet of paper. All right? The assignments that I give you in class moving forward are to be done on a separate sheet of paper. Make sure the assignment is 100% complete. If I collect it and it's not 100% complete, you're going to get a 0 on it. I don't give partial credit for homework. It's all or nothing. Make sure that all your odd answers have been checked in the back of the book and that all of your odd problems are correct. Does anybody have any questions?